Absolute value and distance. If x and y are real or complex numbers such that y equals x squared, then we call x a square root of y. If x is a positive real number, then we say that x is the positive square root of y, and we write x equals root y, where that symbol is the positive square root symbol. Examples. Since 2 squared is equal to 4, 2 is a real number, and 2 is greater than 0, we see that 2 is a positive square root of 4, and we write 2 equals the positive square root of 4. The square of negative 2 is equal to 4, but negative 2 is less than 0, and so we do not write negative 2 equals the positive square root of 4. However, negative 2 is still a square root of 4, and negative 2 is equal to the negative of the positive square root of 4. Since I squared is equal to negative 1, we see that I is a square root of negative 1. Since the square of negative I, which is equal to negative I times negative I, and that's equal to negative 1 times I squared. Now, negative 1 times negative 1 is 1, and I squared is negative 1. So we get 1 times negative 1, which is negative 1. So since the square of negative I is negative 1, negative I is also a square root of negative 1. The square of 1 plus I equals 1 plus I times 1 plus I, which is 1 minus 1 plus 1 plus 1 times I. That's equal to 0 plus 2i, which is 2i. So 1 plus I is a square root of 2i. Let's try an exercise. Find all square roots of I. Okay, now's a good time to pause the video, try this exercise yourself, and then resume the video to check your solution with mine. We are looking for a complex number a plus bi such that the square of a plus bi is equal to I. In other words, we need a plus bi times a plus bi, which is equal to a squared minus b squared, plus 2abi equal to I, which is equal to 0 plus 1i. So we have a squared minus b squared equals 0, and 2ab equals 1. The first equation is equivalent to a plus b times a minus b equals 0, so that a plus b equals 0 or a minus b equals 0. So a equals negative b or a equals b. If a equals negative b, then 2ab equals 2 times negative b times b equals negative 2b squared. So negative 2b squared equals 1, or equivalently b squared is equal to negative 1/2. Since the square of a real number must be positive, this is impossible. If a equals b, then 2ab is equal to 2b squared. So 2b squared equals 1, or equivalently b squared is equal to 1/2. Therefore, b is equal to plus or minus 1 over the square root of 2. So a equals plus or minus 1 over the square root of 2. It follows that the two square roots of I are 1 over root 2 plus 1 over root 2i, and negative 1 over root 2 minus 1 over root 2i. The absolute value or modulus of the complex number z equals a plus bi is the non-negative real number, absolute value of z equals the square root of a squared plus b squared, or the square root of the real part of z squared plus the imaginary part of z squared. Let's look at some examples. The absolute value of 3 plus 4i is equal to the square root of 3 squared plus 4 squared, which is the square root of 9 plus 16, which is the square root of 25, or 5. The absolute value of negative 2 plus 5i is equal to the square root of the square of negative 2 plus 5 squared, which is the square root of 4 plus 25, or the square root of 29. The absolute value of 11 can be written as the absolute value of 11 plus 0i, which is the square root of 11 squared plus 0 squared, or the square root of 11 squared, which is 11. The absolute value of negative 3 can be written as the absolute value of negative 3 plus 0i, which is the square root of the square of negative 3 plus 0 squared, or the square root of 9 plus 0, which is the square root of 9, or 3. The absolute value of 7i can be written as the absolute value of 0 plus 7i, which is the square root of 0 squared plus 7 squared, or the square root of 7 squared, which is equal to 7. Let's try another exercise. Compute each of the following. Go ahead and pause the video, try these problems yourself, and then resume the video to check your answers against mine. The absolute value of 12 minus 5i is the square root of 12 squared plus the square of negative 5, which is the square root of 144 plus 25, or the square root of 169, which is 13. The absolute value of negative root 7i, that's the absolute value of 0 minus the square root of 7 times I, which is the square root of 0 squared plus the square of negative root 7. That's equal to the square root of 0 plus 7, which is root 7. The absolute value of the square root of 15 minus root 21i is the square root of 15 plus 21, which is the square root of 36, or 6. The absolute value of 0, that's the absolute value of 0 plus 0i, which is the square root of 0 squared plus 0 squared, which is the square root of 0 plus 0, which is the square root of 0, or 0. The absolute value of the square root of 6 minus the square root of 11 times I, that's the square root of 6 plus 11, which is the square root of 17. If z equals a plus 0i equals a is a real number, then the absolute value of a is equal to the square root of a squared. This is equal to a if a is greater than or equal to 0, and negative a if a is less than 0. Examples. The absolute value of 4 is the square root of 4 squared, which is the square root of 16, which is 4. The absolute value of negative 4 is the square root of the square of negative 4, which is the square root of 16, which is also 4, and that's equal to the negative of negative 4. Geometrically, the absolute value of a complex number z is the distance between the point z and the origin. Example, which of the following complex numbers is closest to the origin? 1 plus 2i, negative 3 plus I, or negative 2 plus 3i? Well, we compute their absolute values. The absolute value of 1 plus 2i is the square root of 1 squared plus 2 squared, which is the square root of 1 plus 4, or root 5. The absolute value of negative 3 plus I is the square root of the square of negative 3 plus 1 squared, which is the square root of 9 plus 1, or root 10. And the absolute value of negative 2 plus 3i is equal to the square root of the square of negative 2 plus 3 squared, which is the square root of 4 plus 9, or root 13. Square root of 5 is the smallest of those answers. So the answer is that 1 plus 2i is closest to the origin. The definition of the absolute value of a complex number is motivated by the Pythagorean theorem. Let's look at an example to see this. Look at negative 3 plus I in the figure to the right. Observe that to get from the origin to the point negative 3, 1, we move to the left 3 units and then up 1 unit. This gives us a right triangle with legs of lengths 3 and 1. By the Pythagorean theorem, the hypotenuse has length square root of 3 squared plus 1 squared, which is root 9 plus 1, which is the square root of 10. So the absolute value of negative 3 plus I is the square root of 10. The distance between the complex numbers z equals a plus bi and w equals c plus di is Distance between z and w is the absolute value of z minus w, which is the square root of the square of c minus a plus the square of d minus b. Note, the distance between the real numbers x and y is simply distance between x and y equals the absolute value of x minus y, which is the square root of the square of x minus y. Examples. The distance between 2 and 5 is absolute 2 minus 5, which is the absolute value of negative 3, which is 3. Observe that the distance between 5 and 2 is the same. Indeed, we have absolute 5 minus 2 equals absolute 3 equals 3. The distance between 1 plus 2i and 2 minus I is the absolute value of 1 plus 2i minus 2 minus I is the square root of the square of 1 minus 2 plus the square of 2 minus negative 1, which is the square root of the square of negative 1 plus 3 squared, which is the square root of 1 plus 9, which is the square root of 10. Example. The figure to the right shows 1 plus 2i minus 2 minus I equals negative 1 plus 3i. Geometrically, we can translate the vector z minus w so that the directed line segment begins at the terminal point of w and ends at the terminal point of z. Notice that the expression for the distance between the two complex numbers follows from a simple application of the Pythagorean theorem. The distance between 1 plus 2i and 2 minus I is the square root of 1 squared plus 3 squared, which is the square root of 10. Let's try another exercise. For each of the following, compute the distance between the two complex numbers. Go ahead and pause the video, try this exercise yourself, and then resume the video to check your answers against mine. Z equals 1 plus I, W equals 1 minus I. The absolute value of 1 plus I minus 1 minus I is the absolute value of 2I, which is 2. Z equals 2 minus 3I, W equals 5 plus 2I. The absolute value of 2 minus 3i minus 5 plus 2i is the absolute value of negative 3 minus 5i, which is the square root of the square of negative 3 plus the square of negative 5, which is the square root of 9 plus 25, or root 34. Z equals 5, W equals negative I. Absolute value of 5 minus negative I is the absolute value of 5 plus I, which is the square root of 5 squared plus 1 squared, or the square root of 25 plus 1, which is the square root of 26. Z equals 0, W equals 8 plus 9i. The absolute value of 0 minus 8 plus 9i is the absolute value of negative 8 minus 9i, which is the square root of the square of negative 8 plus the square of negative 9. That's the square root of 64 plus 81, which is the square root of 145.